Okay, hello everyone. Thank you for joining this webinar, Microsoft Reactor Toronto. I am your presenter for this session, and I will be speaking on Azure Kubernetes and pretty demo heavy and about running and managing applications in a AKS cluster. So just a little quick intro about me. I'm based out of Toronto. I'm an independent consultant with Azure, more than 14 years of Microsoft technology as a .NET developer, worked with a lot with SharePoint, Office 365, and kind of more recently with Azure and Kubernetes. Graduate from the University of Toronto with computer science. You can check out my blog at www.roykim.ca, see my writings on Kubernetes and Azure and just the Microsoft Cloud platform. I'm also a Microsoft MVP. So the agenda here is a very quick overview. I'll assume you have understand the fundamentals of containers, and then I will jump into kind of demoing some applications I've deployed, and then kind of talk about, glance over kind of the Azure and Kubernetes architecture diagrams I've built out, how to manage your Azure resources, services, and the Kubernetes cluster using various tools. We'll do a quick look at monitoring with Azure and some tools, middleware that I deployed, and then we'll end off with Q&A. This is a live event. I do encourage questions. I'll like to make it pretty interactive. Really, the objective is really demo heavy, and I just want to show apps that are running and how to view them, manage them, and monitor them, and then see it all happening in action, and then come away with a better understanding of how it all fits together, right? So there's a lot of great presentations, and the Kubernetes platform is really huge, and there's many ways to design and deploy and manage. And so I just want to give a kind of point of view how all those things work together. So in a pretty practical sense. Okay, so what is Azure Kubernetes Service? It's a managed orchestration service within Azure. Supports service discovery, load balancing, availability, auto scale, pod and container deployment, right, with your containerized applications, health monitoring, and more. So really, from a standalone Kubernetes service, and I see a question, what's the difference between OSS Kubernetes? I'm taking that as like kind of standalone that you would just deploy or manage yourself in maybe through physical or virtual machine environment. But with Kubernetes, a portion of the infrastructure, especially on the master, is managed by Microsoft, right? So you don't have to do that. So when you create a Kubernetes, like everything's installed and provisioned and allows you to have some configuration settings. And most of all, with Kubernetes, supports a microservices based application. So I'll demo some of that and kind of see and show it in action how that looks like in a Kubernetes environment with in AKS. With AKS, you focus more on application workloads and less on the underlying infrastructure because it's a managed service, right? Provides a declarative approach of deployments, using ARM templates, kube manifest files. You can get like a really agile provisioning and setting up with infrastructure and deploying your applications. With Kubernetes provides a lot of flexibility and versatility with deploying, an application, whether it's .NET Core or Node.js or Java, on any kind of operating system too, right? So you can do it on Windows, given kind of Windows containers, Linux, different Ubuntu or Debian or any distributions, and also like software libraries like .NET Core or .NET Framework or Node.js, and etc. With AKS specifically, there is a customer managed portion and there's that Azure managed portion, which is that cluster manager, right? That is kind of like the brains, right? That schedules deployments on where each application goes in your physical node. So each node is a virtual machine. Some of it would be kind of managed by the customer, right? But all this is deployed configuration pretty in a pretty efficient, agile way. That's the distinction on the difference between AKS as a managed service, right? Where if you're to do it kind of in an unmanaged way, you have to handle all these things yourself, right, and deploy them. The applications I'll demonstrate is the guest book app, a book info, which has a microservice architecture using Istio as the service mesh, a voting app, right, which also leverages kind of Istio and has a MySQL database backend. And so I will kind of show that. And also I have a little very small, simple, like a hello world app, like a single container, single pod application, right? And I'll demonstrate these applications. So actually, before I go to this slide here, let me show you from a UI standpoint what each application. So we have the voting app right here. If I refresh, so all it is kind of you're voting cats and dogs, and some data is being persisted in MySQL backend here, and kind of voting, and you kind of see kind of the tally that's going on here, right? Another application is the a guest book, right? So you sign in, just put your name in here, you know, like Sue, and the name is kind of down here, and it's running in the AKS cluster. Let's see, another application is this book info as well. Right, so as I'm refreshing here, there's three types of kind of renderings, like one without stars, one with red stars, and one with black stars. So so this demonstrates like it's actually going like there's a reviews service, right, microservice, and there's three types, and it's kind of being load balanced evenly across the three, and I'll get into that more. And then a fourth app, which is extremely simple. And if you're starting out, like this is a good one to play around with. If you find the AKS Hello World app, and all it does is you know, just shows this, right? But there's quite a bit of basic concepts as networking and images, container images. So if you're a beginner, I would suggest kind of starting out with this, and then you know, move on to the guest book, and then maybe this voting app, and then this one is more kind of complex with Istio service mesh that you can find in istio.com. You can look for that, and you can deploy that. So so with these applications in a cluster, how can it be organized, right? So the way I have it organized in this type of demo example is that in this cluster, as you see here, I've done it through kind of namespaces. Okay, so they're just basically kind of logical ways of organizing it, and through namespaces, you can, you know, put like role-based access around so that one team only can access or manage, or DevOps engineer can only work with a certain namespace, right? And so that's kind of a logical setting logical boundaries, right, in your environments, right? And that also speaks to kind of governance as well. So I have a guest book, the Hello World, the book info, and the voting app, right? And each little square is just kind of basically your deployment or a set of containers as defined. It could be one container or multiple, and I'll get into that more later. And then there's other namespaces I've created, which is I like to call these more infrastructure, like application or operational infrastructure namespaces that support the app namespaces, right? As I'm arbitrarily calling them. So so they are like software or containers running as well within your AKS cluster. So right here to are your ingress controllers or your ingress, right? So it's a kind of networking and load balancing kind of concept here. So if you want to, and you likely will, expose it outside the cluster, right? You would have an ingress controller, right? There's many types, okay? And this is a big topic on its own. But to keep it simple, I demonstrated that I have two. One is what Istio provides, okay, the service mesh open source library, and also Nginx, right? And then you define routes and HTTP ports, and you have set up TLS, SSL, certs, routing to your applications, right? So as you see here, I have like a domain guestbook.arkin.ca. I have my DNS through a DNS that's not Azure, but somewhere of my own, and then it points to the public IP, and based on the host name, it routes and binds a certificate, right, to that, right? So I have kind of a let's encrypt certificate. So that is dealt with in your ingress, okay? And then down here, I have some monitoring kind of components or software. These are open source software as well, Prometheus and Grafana. Prometheus helps with kind of getting the data telemetry, right, monitoring CPU, memory, disk at a very granular level for each pod, each container, network-wise, TCP packets, etc. Right? Where Grafana is more focused on visualization. Okay, and then Key Ally is also a traffic, like a service mesh kind of visualizer and kind of monitoring and management. So we'll look at that as well. So the takeaway here, and finally is the Kube namespace, which is kind of out of the box, your system, and the Kubernetes dashboard kind of runs off of this namespace. So the key takeaway here is that you can logically organize things by namespace, and in this cluster, there are many applications, right? Like user applications and kind of operational, right? And I'll show that. Now, so apart from talking that's within the cluster, right, the Kubernetes cluster, well, what about Azure itself, right? So where does Azure come in, like the Azure resources and services, okay? So really each node is really a virtual machine, right? Where by default the first set of node is Linux based, right? And you can add a node pool of VMs that are Windows operating system. Okay, you get a load balancer. Okay, to it can be a public or internal facing, but in my architecture that I have right now for the purpose of this demo is public facing, and it has a public IP. I pulled in when I deploy these apps, I pulled in from really a Docker Hub registry, or even a Microsoft container registry. You can do from Azure Container Registry, like a private one. And I have role-based access set up, right? So that is really Azure identity. So to manage your Kubernetes cluster, okay? Using Azure Monitor, I'll show that, log analyst workspace to collect the data, and so monitoring log analyst workspace work hand in hand, and also for persisting data, right? Because Docker, like containers in Kubernetes is stateless, right, and ephemeral. And to manage persistent storage, you can do it within the node, but with Azure, we can leverage kind of managed disk and mount, the kind of external, like a file system or data storage to your containers in your cluster, right? So you can do that kind of externally, right? So I have that set up here. So I have Grafana to store some data, and Prometheus is also using a managed disk. So that's an example that I have set up in this demonstration. So So let's head over to switch over to Kubernetes Dashboard. Actually, let me pause and look at the questions here. Yep.
Yeah, we have a bunch of questions in the Q&A section. If you could take a look.
Yep. Okay, great. So, okay, one question. Can you discuss what can be done in Azure Kube that can't be done in OSS Kube, and OSS being open source software? So I interpret this question as, let's see here. Okay, what can you do in Azure Kubernetes? I interpret that as using Azure resources that you can't do internally, right? Okay, so I think an example would be, let's say, monitoring, right? So, and I'm going to demonstrate this further and show this is Prometheus has some monitoring in place, right? So, you have a choice between using Prometheus and Grafana versus Azure Monitor and Log Analytics Workspace, right? So, so I would say Prometheus and Grafana is pretty powerful. I think that overall it can do what you want, and you may not want to deal with these things like the Azure resources, right? However, what can be done with Azure resources is that you get that platform as a service capabilities and unique benefits, right? So you can set this up quickly. Presumably in some cases, it's managed externally. You can leverage or centralize things with other workloads in your Azure platform environment. Manage costs, things like that. So in terms of manageability, it may have different use cases. Functionally, Prometheus Grafana may be more superior, and we'll talk about that. But yeah, you got to look at from functionality, manageability, total cost of ownership, the enterprise architecture on what they bring to the table, and pros and cons. So I think I'd like to do a future webinar on this subject, right? So hopefully that answers your question on what can be done with AKS versus just within Kubernetes, like standalone using just OSS software, right? So these are more managed by Microsoft. These are you got to manage yourself more, right? Another question. Let's see here.
So if you go to the published section, Roy, there's about 15 questions there.
Okay. I'll go through them really quick. Okay. How can we integrate SSO LDAP authentication on the customer side of infrastructure, and in which namespace would it be implemented? Yeah, I can't answer that quickly off the top of my head. So LDAP, you would either use like some OSS software libraries you can deploy internally for single sign-on. Maybe I've used Auth0 for that. You can use, if you want to go Azure Pass, there's Azure AD, right, and B2C, and maybe there's some kind of integration that comes with that. In which namespace? For me, I would say it's pretty arbitrarily, but can't give any detailed insight into that. Let's see here. Next question. So, is Nginx a load balancer? So, in a way, yes. But okay, in a AKS kind of setup or scenario, this paired with your public cloud load balancer. So this is what so Ingress will configure, will send out configuration to your public cloud load balancer, and this is the same, happens same in AWS and Google Cloud. So it think of it as a controlling mechanism. Okay. Why do we need Nginx when you have a load balancer? Okay, I kind of answered that question, but if you always feel free to email me directly to have a more in-depth discussion. I don't mind. Let's see here. There's a lot of questions, which is great. But can download Kube now? How can I? Okay, can I download the Kube now and run it? But are there limits on Azure Kube? Let's see here. Can I download Kubernetes? You don't download ran it, but are there limits on Azure Kubernetes? Okay, honestly, if you don't have an Azure subscription, maybe that's your challenge. Is that would you want to use a local Kubernetes cluster? You can use Docker Desktop Engine, right? That is your starting point. Are there limits on Azure Kubernetes? Not that I know of. It's pretty open, right? I can't think of anything off the top of my head. But if you're starting out, I think it's fine. Okay, I'll do one more. Okay, can you elaborate more on Windows containers? We haven't seen many in production, so it would be very interesting to compare them with Linux containers. So I believe that Windows containers has finally gone kind of GA, global, generally available. There are quite a bit of limitations. I feel like that Windows containers story is catching up. And there's also not a lot of open source kind of software and libraries that are ported over to Windows containers. So there is a lag, but it's something to watch out for. And if Windows containers is really your thing, you know, I believe that there's continue to be you know, work on that with the from Azure, right, to support those scenarios. So production, yeah, you won't see much because of those reasons, but that's what I have to say about that. Okay, so I have to move on with this presentation, but email me if you like to discuss further. Okay, so let's go to the Kubernetes dashboard here. Let's see here. So I got logged out here. Okay, so your first kind of management tool with your cluster is really it's your so at the cluster level, as you see, we have kind of 3 nodes here, right? So it's really 3 VMs. So in your CPU usage, your memory usage, and the first thing that I look at is really the CPU requests. So each container makes a request of getting a slice of memory and your CPU cores, right? So all the containers that's provisioned is requesting and allocated 80%, right here. This one 93% and 65%, right? So that's kind of what I pay attention to. And then there's auto scaling that AKS provides that will deploy another node and deploy more pods and containers to that, right, if there's more requests. But it doesn't mean that they're all fully utilized. But in terms of CPU usage, it looks like it's just 10% is actually being utilized here, right? So next thing are persistent volumes. Okay, so storages that are leveraging the managed disk there, and then in terms of namespaces, we can kind of toggle through the various namespaces, right? So one thing I'll say is the book info, and so that book info app that I showed, we can see its CPU usage, right, 0.04, and its workloads, right? So we have certain deployments, its pods, which contains 1 or more containers as necessary, replica sets, and services, which are kind of networking abstraction layers that point to your deployments. So deployments, you can have, you can manage its kind of manually its scalability right here. So let's see here, I go to scale, click on that, and I can increase, you know, the number of pods, right? And then it can be load balance. Any request to this microservice or service, it can be load balance across the 2. Next, we have our kind of ingresses, right? It's not defined here, but it's defined in a different namespace for the book info app. And let's see here, services, as you see here, which again is a networking abstraction that points to those. These are the internal cluster IPs, configuration settings, okay, key value pairs, again, persistent volumes, if any, secrets, right? You know, like storing like kind of TLS certs, etc., tokens, etc. So certificate there, you know. So you know, this is all in my just demo environment, and so that's an overview of kind of the dashboard. Actually, I'll kind of show all namespaces here and kind of go an overview, and we'll see here. You know, just across the board, you know, all your deployments and Kubernetes workloads and objects to manage, you know, its usage, to see resource utilization. So in terms of the ingress, so we have here the Nginx ingress controller, and that is mapped to a public IP, right, that Azure provides. If you click on that, if I click on this, I'm not sure if it'll actually go into it, but yeah, that points to a, let's say if I go to the voting app, you know, that basically that IP address is working with this DNS. So that's how that works, right? And when I have a DNSA record. So that's Kubernetes Dashboard. Let's see here. Let's see, look at the questions. Do you open this Kubernetes dashboard from Azure? No. So this Kubernetes dashboard is really an application in the cluster, and it has to be done separately from the portal. So, let's see here, clicking on this. Oh no. Okay, no, it's okay. So if I go to Kube System, okay. And really if I go to find Kubernetes dashboard right here, right, that is really serving from the AKS cluster, right? So so I have like an internal kind of port. It's not public facing, but as you see, localhost, it's kind of proxied in from my local computer through the Kubernetes kind of AKS API management API. So that's how that's working. To answer your question, what are the minimum requirements for VM to create a node? I would say for me, I just go with 2 cores, right? You can make them. I don't know if there's any official recommendations, but if you want to go 1 core, but 1 core is really tight. I just go with 2 cores if you're kind of dev test or 3 cores. That's what I would do. But production, yeah, you want to do at least, I would say at least 3 cores with at least three VMs, 3 nodes, you know, and do the auto scale. So that's a brief kind of walkthrough of what that looks like and how apps are managed through namespaces, and I can hone in on those and see the CPU and memory usage. So that's kind of one point of view on that. If we go to, let's say, the Azure portal, how to manage the cluster through that, or the Azure resources. Let me see here. So switch to this. So let's go back at top. So we have here, it's deployed to a region, and some notable configuration is really your node pool, the Kubernetes version, and we can here do scale them up, right? I have auto scale at the moment, but you can do manual and then add manually scale out your nodes in this fashion, right? You can also add another node with Windows as well, okay? And other notable things is that which I'll get into more later. If you go to Insights, we'll see kind of your monitoring, right, of your node serialization, memory utilization, node count, active pods. So I've done like throughout this morning, I applied some load testing and stress testing to activate kind of horizontal pod auto scaling. So, you know, as you can see here, some pods have been created, and then when that stress test finished, it would scale back down. Okay. Also, we can go and look at metrics and look at different graphs for your monitoring here. So that's, and then if we go to properties, so there's a special what you call infrastructure resource group that gets created. Okay, and let me make it bigger here. So all these resources here were provisioned by kind of configuration. Okay, we have a VNet that comes by default. Here's that node pool. Okay, network security group, and we have 2 public IP addresses, right? So through that ingress controller, like the Nginx or the Istio, when I created an ingress rule, it actually went out to the load balancer, created, added some routes, right? And also asked for a public IP address, right? So so I have 2, one for the Nginx and one for Istio. So the key takeaway here is that I didn't create them, they're automatically done, right? In that, again, in that managed way. These are managed disks, right? One is for Prometheus, one is Grafana, and one is for one application, the voting app for supporting the MySQL database. And again, these are also automatically provisioned through the kind of the deployment manifests as well, right? And we have managed identity. So these are kind of like these are really service principals underneath the hood, and give AKS, right, access to other Azure resources, so that within the cluster, right, it can you know, apply configuration. So here's the load balancer. Okay, front end IP, the 2 IP addresses, the backend pool that's pointing to the 3 virtual machines, as you see here, 1, 2, 3, and load balancing rules, right? That get added, and basically the ingress controllers kind of take over kind of this configuration. So you shouldn't really touch this. I believe that if you even modify these things, the ingress controller will notice and will kind of, in a desired state fashion, will reapply what it was, what it should have been originally. So keep that in mind. Let's see here. I'll go back to the questions. Could you please suggest how to deploy a Docker image into Kubernetes cluster? How do we get this dashboard? So to deploy a Docker image into AKS, you know, you grab it from a registry. So it could be your private registry, Azure Container Service, Docker Hub, Microsoft has one, Google has one. And some approaches using Helm in a very easy packaged way, or you use Docker commands, right? Kind of like Docker pull, kind of in a kind of low level way. And how do we get this dashboard Kubernetes? It is through, let's see here. There's multiple ways. Okay, I'll show one easy way. Okay, so right here I have VSCode, and this is again another management tool, right? And you install the Kubernetes VSCode extension. This is my cluster I have right here. It gives your namespaces, and when I go right click, I go open dashboard, it will run a command kind of open up a tunnel from your local computer to your AKS cluster, and your browser will pop up, right? That's how you load up the Kubernetes dashboard. Okay, hopefully I answered your question there. So so while I'm here, this is another way of kind of managing your in a command line interface ways using kind of kubectl, right? So kubectl, you can say get nodes, right? And that will show my 3 nodes. kubectl get pods, right? You can do /n by namespaces. So let's say my voting app, these are my pods. And you know, describe the horizontal pod auto scaling, kubectl top nodes, which will show kind of my CPU memory utilization at this current moment, right? As you see, so that's just a quick example of how to manage and operate against your cluster and your applications. Okay. Let's see here. So moving on. Let's see. Okay, so other dashboards. Okay, so let's talk about Key Ally. Okay, let me do a load. Let me apply some load testing here. Let's see here. Give me a moment to bring this over. If you can see that. Okay, we'll do it. Okay, I think it's not showing in your screen. Okay, nevertheless, okay, let's do another way. So I have this tool called Siege, right? And it is kind of a load testing, right? So I have a URL, I have 250 concurrent requests, and let's load that, and then that's working. This is kind of expected. I'm working with Windows subsystem for Linux, and that invalid argument comes up, but it's working as expected. So that right now is adding some load into the cluster, into that voting application. And let me turn over to the Kubernetes dashboard, refresh here. Let's see, and should see some activity there. Actually, wait a minute. Actually, you know what? Let's close this. Okay, actually, let's run this one, the voting app. Okay, and then I will show Key Ally. Let's see here, Key Ally console, refresh. So right here, it's like kind of a service mesh visualizer when you're working with Istio as a service mesh. So I filter by the voting namespace. So this is a voting app. So you can see it's kind of a bunch of microservices, the voting app, kind of the front end right here, the analytics, which is just tallying the counters, or whether you're voting for cats or dogs, it's really tallying it in here and providing that percentages that you saw, and then the voting storage, which is MySQL, right? You see like different versions, like 1.10, 1.1, and 2.0. So that's just to demonstrate that you can deploy different versions and then switch your traffic between the two, right? So you can have more managed kind of rollback and A/B testing and canary testing, right? So that's the value of having a service mesh, or those type of scenarios, right? So let's see here, and then I can display the traffic animation. And right now you see the request percentages, okay, going through. Let me demonstrate the book info app. as well. Show that as well. I have, let's try this. So bookinfo.arkin.ca, add some traffic going into that. And go to Key Ally. Okay. Hopefully we'll see some activity. Okay, let me refresh. So display traffic animation. So here, what we're seeing here is that book info app. So the product page is your kind of your HTML UI front end, and then it splits off to your details and your review service. So you can see that the traffic split 50-50. You have your review service, and that shows the stars, right? Let me bring up that visualization, the application here, right? So you have this thing right here. Okay, as I'm refreshing it, it's slow to show up because we have some load in here. So the reviews is like the number of stars. So there's no stars, red stars, and black stars. So that demonstrates kind of the load balancing that's happening here, kind of evenly. Okay, so you can say, okay, no stars is version 1, version 2, version 3, and then when you're testing, maybe you're doing, canary testing, and when you feel like you added, like 5% of the traffic and it's stable, then you can start to, bring everything over to your latest version, right? So that's how to kind of manage the deployments there. And then this service going to another service like for ratings, like the number, right? And to show that like the number of stars, out into your page. So that's a demonstration of that book info app using this kind of Key Ally tool, which is again hosted in your AKS cluster. Okay, let me turn over for one question here. If there's, let's see here. Okay. Could you please suggest how to deploy a doc? Okay, we already did that one. What is Siege? It's just a command line stress testing and load testing tool that I just shown, which applies some traffic there. You can look that up. Are those names in the load balancer rules the names of the pods or the nodes? They're not names of pods or nodes. They're just arbitrary names of the rule itself. That's what I think. Could you please, okay, zoom in, letters are small. Okay, I'll try to do that. So, okay, we'll move on. I think that's all the questions for now. So that's the Key Ally dashboard, right? Again, this is the microservices architecture that we saw here, right? And the voting app, right? So here's another snapshot of the traffic that flows through, right? And there's different versions that you can route the traffic to, okay? So the next thing I'd like to quickly show is kind of horizontal pod auto scaling. So what this means is that, like for example, this voting app, like the front end, there's really only one pod, right? And you can horizontally scale that pod to have more replicas, like 2 or 3, So for the guestbook app, when I go kubectl describe HPA, right, horizontal pod autoscaler, I can see that I've defined one HPA kind of like object, right? And as this was under load, under stress testing, it was at 318%, and it would scale out at a target of 50%. So that would trigger auto scaling, okay? The minimum number of replicas and the maximum number is 1 and 5. So this got deployed with a heavy load, had 5 pods. Okay, and then you kind of see the events here, right? CPU resource utilization was above target, so let's add more replicas or more pods, right? So that's an example of the pod autoscaling. Okay, now let's turn over and take a look at some other kind of tools. So one is Prometheus. Okay, so this collects telemetry across your cluster, and one thing I'm showing here is the CPU usage over 1 minute duration, right? For that. So as I execute this, let's see here, I just refreshed. I've done some kind of activity and intermittent kind of stress testing with Siege, and you kind of see the difference here. So here you get a very fine-grained fine-grained kind of data, where Azure Monitor can get similar data, but it's not as detailed as Prometheus. Okay, and then if we switch to the Grafana, okay, so Grafana works with Prometheus, okay, and you can take that query that I have from Prometheus, and so it's just a better kind of visualization, right? An alerting mechanism. So we have the same kind of data through here, right? It also provides some dashboards out of the box. So there's some Istio dashboards, performance workload dashboards right here. And so these come with the install, right? And you can get more different types of dashboards. Like this doesn't have to work with Prometheus, but Grafana can work with other logging systems. I think this can even work against even Azure Log Analytics Workspace too, right? And then build out charts and dashboards and alerts, right? So I think example here, so I have the voting app filter on that. And then you'll start to see where data has been collected. Or I think maybe the voting too. It's a little slow to load. Okay, let's try book info. And where there's data available, incoming requests, errors, like, at the HTTP level primarily, right? You can, filter out by status codes. I've done that in projects where I made like custom graphs by status code, like 200, 300, 500, 404s. So here we see that happening right here. So yeah, it's really cool. I like it. You won't get this level of detail and sophistication with kind of Azure Monitor, right? You can do it in log analytics and build out your queries, but the query language, after some time of learning, it's more natural to the way that the data is structured, which is a time series database. Okay, so that's an example of Grafana, and that works against the Prometheus. And again, this has this, some of this data is being saved through a managed disk as used as persistent storage. So that's that. Okay, I'll look over for any questions here. Okay. So when you deploy a new app version, how do you know that the old app is no longer in use? By user how to gain that zero downtime here. So the way I'm understanding this question is that I guess you're trying to divert the traffic and make sure it's all drained, I guess. How do you know? So I guess you would use tools like these to see if there's any lingering traffic using kind of Key Ally and here, so against that specific pod. So I would say I would use that tool. This tool, maybe there's something with kubectl. Maybe we'll go right down to that detail if there's traffic to a service. But I would, in my opinion, I would look here. I'm sure there's other options. For another question, for service-to-service communication, say you are developing on your local workstation and have one microservice making a request to localhost port API method. What do you have to change this to make this work inside the cluster? So that to me is really using the service object, okay, and your ingress. So I would look there for service to service. Hopefully I answer your question there. Okay. If I didn't, yeah, please email me. What tools do you use to deploy Kubernetes master and minions with the container engine? So I don't understand minions. What tools to use to deploy Kubernetes master? If you're talking about that master kind of node portion, I would have to say like AKS just does it for you. Yeah. How do you set up and run these Grafana Prometheus? So there is you Google for like Helm charts, right? And it's pretty straightforward in that way for a basic setup. And you just Helm and you install it. You point it to your cluster or namespace. Make sure you're already logged into your cluster, and you do it through the command line. It's really pretty easy for just a basic setup, but of course for production, you got to look at all the settings and kind of craft your configuration. So if you install Istio will install Grafana Prometheus as one big package. So there's like a demo style install. So if you just look up the Istio documentation, it's like one line of configuration and some flags to say Grafana equals true to enable, and off you go. Okay, cool. So let me wrap up and answer any remaining questions here. So let me go back to my slides. So here I've shown that Grafana. So this is Azure Monitor. I showed that already. So in summary, what I've shown was you can run multiple applications in the same cluster, right? And I think it's really cool. It's really nicely knit together, and exposing those applications via an ingress and ingress controller. Use the Kubernetes dashboard for the cluster management, right, within the cluster. I would recommend Istio Service Mesh, although there's different options. I haven't tried those other options. I think like Linkerd or Calio or something are other options to support a microservice architecture. Use the Azure portal to manage your Azure resources. Prometheus and Grafana for the cluster monitoring and a fine-grained approach, using Azure Monitor for containers along with the log analytics workspace that stores the data telemetry, kind of more coarse-grained. I like to go with both, but with this Azure Monitor, you have to obviously pay for it, like by the data storage and retention. And so that's hopefully the takeaway. You kind of saw how a bunch of things work together, and kind of helps you kind of in your learning paths. So to end off, maybe a few minutes, I can answer any more questions, but here's my email and my blog, my Twitter. Feel free to contact me for any questions. So I'm looking at the chat window. How can I configure a dashboard as a container and reach it using a public IP? So you have to set up an ingress setup, right? Ingress through the Nginx controller or Istio. Usually, from best practices and security, it's not recommended going through because if there's some you have a attack vector there, right? That can get into it. So it's best to keep it internal, that the access internal in your network or virtual network as much as possible, and to explore private clusters, right, where the Kubernetes API server doesn't go through a public endpoint, but it goes through internally, right, through internal, like kind of your virtual network. Any other questions? So I'm scrolling up. If I missed any, why do we need the service mesh? Okay, so one question is previously, why do we need the service mesh like Key Ally? Can we do without it? Or is there anything in Azure that natively supports these features? So definitely you can do without it. So an example of like the service mesh kind of technology or OSS kind of library or framework is that to manage the HTTP traffic at a very fine-grained level. So like doing things like HTTP retries, like circuit breaker, if a service is getting overloaded, then and you don't want to overload that service, but you have to compromise by having other requesting services being shut down from requesting that. So very fine grained. Like, so to do like layer 7 traffic management, you can use the load balancer, application gateway, maybe API management. You can do those, but it's case by case depending on your scenario and what you're trying to achieve. But you do not need service mesh. But for microservices architecture scenarios, it helps. Let's see here. Thanks for... Any other questions? Okay, great. That wraps it up. Eamon, if you want to conclude or...
Yes, so thank you so much for joining, everyone. Thanks, Roy. If anyone has any questions, I think Roy's socials are right there. And you can also continue the conversation on the meetup page for this event. So you can find this page on the Reactor Toronto meetup group and a couple of other locations as well. We have a whole bunch of other sessions coming on, and Roy will be hosting more events like this almost every month. And we have daily events happening, so things that are more relevant to you. If you're interested in more Azure events or data science or machine learning, you can check out our meetup page. I'll throw a link down below. Otherwise, you can see the recording of today's session on our YouTube page shortly. And thank you so much.
Okay, thank you. Bye, everyone.